This is LeetCode Roulette, let's spin it. One question today from the LeetCode 150 for 150 days. And we got decode ways, let's code it. Okay, you have intercepted a secret message encoded as a string of numbers. The message is decoded via the following mapping: 1 to A, 2 to B, 25 to Y, etc. However, while decoding the message, you realize there are many different ways you can decode the message because some codes are contained in other codes. A good example of that is example 1, where we have the input S is equal to 12. 12 can be decoded as A and B, meaning 1 and 2, or L, just 12. Given a string of S containing only digits, return the number of ways to decode it. If the entire string cannot be decoded in any valid way, we're going to return 0. Now I'm going to code the top-down dynamic programming solution. So I'm going to start with a DFS function that takes in an index. That'll be the index of the string, and there'll be 2 base cases for this. The first is if I is greater than or equal to the length of S. In that case, we've reached the end of our specific decoding, and so we're just going to return 1. The next base case is if to handle this invalid code, for example 06, we're basically just going to treat that as that if any time the current index is equal to 0, we're just going to return 0. So we're going to go like this. So if Si is equal to 0, we're going to return 0, meaning there's 0 number of ways we can go from that point onward. Now we're going to define ways recursively as the DFS of I plus 1. This case is basically taking each integer at its face value. For example, 1 through 9. This is what this case will handle. However, we need to account for that second case instead of just 1 or 2, for example, for 12. So we're also going to add an additional check of if I plus 1 is less than the length of S, meaning it's in bounds, and the integer of the current index plus that next index is less than or equal to 26. That's the maximum possible range for our decoding. In that case, we're also going to append to ways our DFS I plus 2. This is the case in which we take a 2-digit number. And after that, we are pretty much done. So we're just going to return ways, and then from here, we're just going to return DFS 0. Perfect. And what you're going to notice here when we submit it is it's going to be too slow. That's because this is the backtracking solution. So in cases in which we are doing a lot of repeated work, for example, a long sequence of the same number, we do not need to compute this over and over again. And what we can do here, actually, the easiest way to memorize a top-down DP approach is just doing from functools import LRU cache. Just a function decorator, so we don't actually have to save the set of the number of ways in a map, and it'll just handle it for under the hood for us. And it is accepted. That is the top-down dynamic programming solution for num decoding.